Alrighty, in this video we are going to be talking about arc length, or the length of the curve. There's one formula that you really need to know. It's this formula right here. The integral from a to b of the square root of 1 plus the derivative square, given that the derivative is continuous from a to b. If the derivative is not continuous from a to b, then you can't use arc length. Now there's another version of arc length where if your bounds are now in terms of y, and everything's in terms of y, then it's just going to be the same thing except everything's in terms of y. So c and d is in terms of y, you have g prime of y, and then this is in terms of dy. Now, whenever we talk about the length of a curve, essentially it's asking about finding the perimeter of something. In this case, if I give you a function like this right here, and ask you, okay, find the arc length of this, or find the perimeter of that, then you're using this formula right here. The arc length function is given with this, and this is going to be related to, let's say, related rates in terms of whether the length of the arc is increasing or decreasing. And we'll talk about that whenever we do number 3. But looking at number 1, you want to find the length of the arc of y squared is equal to x cubed between the points 1, 1, and 4, 8 by solving for y. Meaning that everything should be in terms of x's because we're solving for y. Now if we solve for y, then we get plus or minus the square root of x cubed. But in this case, because my points are between 1, 1, and 4, 8, I'm only taking the positive parts. So this is now saying the integral from 1 to 4 times the square root of 1 plus f prime of x squared dx. Now, if we know that this is f of x right here, which is the square root of x cubed, aka, let's see, x to the 3 halves, then the derivative here is going to be 3 halves x to the 1 half. You want to put your derivative inside the function here. So you have the integral from 1 to 4 of 1 plus the derivative, but then we're squaring it. Notice we're only squaring the derivative, not the 1, not the radical, but just the derivative. And then at this point, you're going to put this into your handy dandy calculator and see what this is from 1 to 4.
And then come back up max right there. So what's that now?
That gives us 7.6337.
Now, what did we do wrong? Yeah.
Now, we're going to do the same thing for number 2, except this time we want to solve for x, which means that everything should be in terms of y. Meaning that your bounds are in terms of y. Lucky for us, that means that instead of going from 1 to 4, this is now going from 1 to 8. This is dy. 1 plus f prime of y squared. Now, we need to figure out what this is in terms of solving this for x. So I'm going to just take the cube root of x, call it a day. Now, if I take the cube root, that's going to be y to the 2/3 is equal to x. And then if I take the derivative of this, I get 2/3 y to the negative 1/3. So then 1 to 8, the integral from 1 to 8 plus more times, well, the integral from 1 to 8 of the square root of 1 plus 2/3 y to the negative 1/3 square dy. Now, because my bounds are in terms of y, your answer should be the same. Now, even though this thing does say dx, that's going to be okay. Don't be scared. Don't be afraid that it says dx, because we're just assuming that the x is now y here. And notice how that gives us the same answer of 7.633. So whenever I ask you, okay, find the arc length or find the perimeter, this is what I mean. So, same answer, different process depending on if you're solving for y or solving for x. For the most part, it's going to be solving for y here, where everything's in terms of x. But there might be times where you might have to do number 2.
Okay, so your amplitude is,
Okay, so for number 3, we want to consider the length of the arc along the curve described by f of x is equal to x squared plus 5x for 1 to k. K increases at a rate of 3 units per second. How fast is the length of the arc increasing when k is equal to 5?
no, but the only reason why it's negative is
Okay,
so yes, there's a negative in front,
so
yes, you're missing.
we know that the arc length formula is just s of x is equal to 1 to x,
This shows me that my
the integral of 1 plus, let's see, that's 2x plus 5, so 2t plus 5 square dt.
but
Now, if we take the derivative with respect to time, then we will get,
right, very good. So it should be a negative. Very good. Now, let me see something like that. Could it have been a cosine? I started here.
I don't want to say that, ds dt is equal to 1 plus 2x plus 5 squared times, times dk dt,
Because cosine started the math.
or dx dt, in this case, because I have x here, dx dt. Oh wait, it should be k. Oops. So let me put that as k. Let me put this as k. Let me put this as k.
Very good. Very good. So what's your midline is already at 30. So anyone that has 50 is right.
Which means that that isn't x, that's k. This is dk. Or that's the derivative. S prime of k. Okay, so that means that we have, let's see, what's happening when k is equal to 5. So you're going to plug in 5. And you know that k, dk dt is 3. So if you do all of that, you're going to get 3 root 226.
Looks like they're all cosines. So if I'm starting my cosine, I'd probably just start doing
And then for number 4, it's asking us what's the length of the arc along the curve y is equal to g of x for 2 to 4. So we need to take the derivative of this, which then gives us
here. Do you see a plus sign?
x squared plus 6x plus 8 times 1 by using chain. So then we get the integral from 2 to 4, this rate of 1 plus g prime of x squared dx. Now, if we square g prime of x, the radical will go away.
Okay, so let's see.
So now I have x squared plus 6x plus 8 dx. Then we get x squared plus 6x plus 9 dx. Then we get x plus 3 square dx. The x plus 3 square and the square root will cancel out. So now I have the integral from 2 to 4 of x plus 3 dx from 2 to 4. And then once you do that,
So that's set 2 pi over b equal to 4 pi over 5.
2, 4, 2 plus 6, 8 plus 12 minus 8 gives us 12. So our answer here is 12.
So b equals 10 over 4, which is
All right,
5 over 2.
that's essentially it for arc length.